Thanks for your interest in serving your community as a storm spotter. This training should give you the basic information you need to be able to safely observe storms, to correctly identify key features, and to make high-quality reports. We've talked about the most important cloud features to look for and how to find them in a storm, but wall clouds, funnel clouds, and tornadoes are all relatively rare compared to the scary-looking but not dangerous clouds we see with just about every storm. When observing the base of a thunderstorm, you'll notice there is a lot of turbulent motion, but it's really important to be able to tell the difference between moving clouds and rotating clouds. Clouds are always moving in and around thunderstorms, and spotters can use that cloud motion to help them know what's going on with the storm. Most of the time, moving clouds aren't anything to be concerned about, but when the clouds are rotating, it can be very important. Rotation is defined as organized, sustained, focused cloud motion around a vertical axis. In this diagram, the cylinder represents the cloud we're watching. Rotation would be cloud motion like a merry-go-round in a circle around the imaginary pole running through the middle of the cloud. This motion would be focused around this axis and persistent for several minutes. If you see clouds moving, but they're not focused around a vertical axis like this diagram, then it's not rotation. Most of the time, the cloud motion you see is not rotation. It's very common to see clouds that appear to be moving around a horizontal axis in the same way that the wheels on your car roll along the highway. This happens quite often with shelf clouds and in the downdraft outflow part of the storm, where air is coming down and blowing out away from the storm. Spotters should not refer to this kind of cloud motion as rotation. Scud clouds are ragged, detached clouds that form in and around thunderstorms. These scud clouds actually represent rain-cooled air. Because that air is cool and humid, it allows clouds to form closer to the ground when compared to the thunderstorm's main updraft base. Scud by itself is harmless, and it is very useful to spotters. Scud moves along with the wind, so you can watch it to determine whether the storm has inflow or outflow. Scud clouds can take on the shape and appearance of more important cloud features like funnel clouds and tornadoes. It's important for spotters to know the difference between scary-looking ragged scud clouds and the real thing. Remember that wall clouds, funnel clouds, and tornadoes form in the updraft region of a supercell storm. They are usually organized and persist for at least several minutes. The dangerous cloud features will also be rotating. Scud clouds will typically be blown around by the wind underneath a thunderstorm, and their shape and orientation usually won't be persistent. They usually form in and around the downdraft area of the storm, and although they may move quite quickly, the motion is not truly rotating. We have one more type of cloud to discuss, and that is the shelf cloud. A shelf cloud is a low, horizontal banded cloud attached to the base of a thunderstorm. Rising cloud motion often can be seen in the leading outer part of the shelf cloud, while the underside often appears turbulent and wind-torn. Generally, a shelf cloud appears on the leading edge of a storm. Portions of a shelf cloud can sometimes be mistaken for a wall cloud because of their dark and ominous appearance, but there are some key differences. You've already seen that wall clouds form beneath the storm's updraft. Shelf clouds form along the leading edge of a strong downdraft area. They are at the leading edge of the rain-cooled air as it hits the ground and spreads out away from the thunderstorm. Downdrafts and shelf clouds are generally much larger than wall clouds and can span across much of the sky. Scud clouds will behave differently in the vicinity of a shelf cloud. The scud will remain detached and move out away from the storm following the outflow winds. You can usually identify a shelf cloud by the large amount of rain behind it. Again, these clouds can look very ominous and turbulent, and they do represent a severe weather threat in the form of wind and hail, but significant tornadoes are not likely to be associated with a shelf cloud. Cloud motion on the underside of the shelf cloud is disorganized and does not persist. As the shelf cloud approaches, watch for the wind to shift and the temperature to drop just before the cloud arrives at your location. Once a shelf cloud forms, it usually signals a transition towards storms that are more dominated by outflow and possibly growth into a squall line. You will probably want to seek shelter before the storm hits, as the arrival of a shelf cloud can be followed by severe winds, heavy rain. For more details about cloud features and storm spotting, check the Weather Spotter's Field Guide available at this address.